Assalamu alaikum warahmatullahi wabarakatuh. Welcome back, my friends, to my YouTube channel Abdelaziz Gabr. Today, inshallah, we will talk about a new topic in the deep water drilling, and we will talk today about very important thing. It's called the marine riser. So please pay attention for everything we will talk today because it's very important to listen today. Actually, the deep water riser system, it consists of two, depending on the phase in the well. So it could be during drilling, it's marine drilling riser system and production riser system. So today we will talk about the marine drilling riser because we are talking about drilling phase in this course. As you see here, this is the submersible rig, and actually what is the meaning of the riser? Actually here this is the sea bed and this is the rig. So we should have conduit or pipe to transfer the cutting from the well to the surface. So this is called the marine riser. So this is called the marine riser. Actually this marine riser is composed mainly of the following. Here this is a wellhead connector and above BOB above it. Then we have low marine riser package and lower flexible joint, which is very important for the due to the heave and wave and so on. Here also this is the riser with the choke line and kill lines. Then after this we have telescopic joint, which is very important to compensate for the vertical movement due to the waves and so on, and tension rigs to keep it the riser under tension all the time. And we have here the diverter in case we have shallow gases, and here the upper flexible joint is here until we reach to the rotary table, by the way. So here as you see here, this is the marine riser. Actually it has a fill-up valve. This is very important, and it all the time it comes as a question in the IWSF. Why we have fill-up valve? Because during drilling you may have inside for any failure, yani if there is any failure could happen here in this system, so it can fill up automatically from the water, yani in the ocean, so it can avoid any collapsing for the riser, yani. Okay, so this is very important. As you see, this is the riser joints. As you see, it's very long, and this is very large also. So that's it. Here this is the bare joint. As you see, this is the bare joint, and we put around it something called buoyancy modules. It helps in the buoyancy factor and so on, because we don't need to make very high weight over the BOP and so on. Then the final assembly in its final shape is like this. So this is a bare joint, and this is the buoyancy models, and this is a combination of both of them. Okay. So here the marine drilling riser, what is its component and what's it actually? Actually, a marine drilling riser system is a temporary extension of wellbore to the surface. So it's temporary means during drilling we put it, but after drilling we pull out a hole with the POP to the surface. Then we remove it after finishing the job, by the way. Okay, so as you see here, this is a temporary extension. This is a temporary extension of the wellbore to the surface. For example, the connection between the subsea BOP stack to a floating surface, facilitating the mud returns to the surface. So its main function is like the conduit to the surface for the mud return. Okay. As you see here, marine drilling riser system. The marine drilling riser system, it connecting the drilling floor to the subsea wellhead. So as you see here, this is the wellhead, and above it the BOP. So all of this is called the marine riser. Okay. So the subsea well is drilled through the riser string, allowing the drilling mud to circulate back to the rig. Okay. Risers are supplied with a selection of auxiliary lines such as choke line and kill line, booster and hydraulic lines with the maximum working pressure up to 20 kbsi. Up to 20 kbsi. Okay. So here the risers can be supplied either slick or with buoyancy modules, as I told you, installed. So the riser can be also supplied in effective lengths of 5 feet up to 90 feet total. Okay, so that's it. What is the component? Actually, the first component is the diverter. As you see, this is the diverter system, and it's very important due to the shallow gas buckets, and if you have a shallow gas well during drilling, by the way. So this is a diverter system, and you have to take it to put it in the marine riser upper valve, upper يعني in the upper of the marine riser. Okay, so during drilling operation, the diverter system is used to protect against shallow gas kicks. This is very important. If there is a shallow gas kick, the diverter is energized to seal around the drill pipe and divert the gas through one of the overboard lines depending on the wind direction. So it can be with the wind direction, by the way. Actually, here this is the upper section of the marine riser, because we have lower section also of the marine riser. So this is the upper section. As you see, this is the marine riser diverter assembly. Then you have flexible joint, which is very important, as I told you. Then a telescopic joint, which is very important for the vertical waves comes and on, ups and downs. Here we have, this is the riser tensioning lines, which are very important, and finally we have the kill and choke lines here. Okay, so this is very important, as I told you. Okay, here as you see, this is the telescopic joint. Telescopic joint means one inside one. So the telescopic joint, as you see, or TJ, it's very important because it consists of inner and outer barrel and backer housing barrel latch. The backer housing barrel latch is and tensioner ring and also auxiliary lines. But here the most important point you have to take into consideration, the backer is the weakest point in the marine riser, in the telescopic joint, because if you have any gas inside the marine riser due to any problem in the surface hole or in the gas bucket, actually this will lead to damage the backer. So it's the weakest point in the marine riser. Okay, and this is IWSF question, by the way. Here the TJ compensates for the heave and offset of the vessel and is available together with the riser system. Okay, this compensating movement is achieved through stroking of the inner and outer barrel ups and downs of the telescopic joint, by the way. Okay, so to remove the need for rope riding operations and the associated risks, a range of hydraulic latch and auxiliary line remote connection solutions are available. So this is very important, as I told you. This is the telescopic joint, this is the outer barrel, and this is the inner barrel. So this is called the telescopic joint, as I told you. The backer housing is very important, as I told you, and it's the backer is the weakest point here. So a total of 12 dogs secure the qualified hydromechanical backer housing of the telescopic joint. This is very important. And the both upper and lower backer benefit from the backer wear ring indicators, and this backer, as I told you, is the weakest point. So these features enable live monitoring of backer condition, providing predictable backer change out with fast and easy access to the backer elements, by the way. Okay, this is the mud boosting line termination joint. Okay, it increases the circulation rate to increase the solid transportation efficiency. Here we have the tensioning rigs. Tension rigs attached to the telescopic joints and from termination points between the riser system and tensioning system on the floating rig. They are used to pull and support tension to give the riser string more stability. So it's very important as it gives it more stability. As you see here, this is a hinged ring, as you see, and it is used for tensioning because as you see this is here, so it can be used for tensioning of the riser, by the way. So we have SDC tension rings. The SDC tension rings utilize a ball joint connection with direct line cylinder tensioners that are permanently attached for fast and safe attachment to the telescopic joint. A hinged split ring, as you see, this is hinged split ring design, opens and closes around the telescopic joint. Opens and closes around the telescopic joint. SDC rings are designed to be opened and moved out of the way for storage while the tensioning cylinders remain attached. Okay, an optional KT style termination ring can be also utilized with the SDC tension ring. Okay, here we have very important thing. It's called the flexible joint, and this is the flexible joint. It's we have a lot of here. So we have number one, diverter flexible joint, which is below directly the diverter, and the diverter here is installed at the top of the riser below the diverter, as I told you, housing where it will encounter significant compression. It's capable of free angular rotation plus minus 15 degree up to 4,000 kilopounds tension and 500 psi maximum pressure. The diverter flexible joint is available in different configurations based on the maximum working tension requirements. The diverter 2 is flexible joint. So diverter 1 and here is the diverter 2. Flexible contains of two flexible elements, double-ended for applications requiring rotation at both ends. Each flexible element comprises a primary and secondary flexible element. And finally here the diverter third flexible joint utilizes one flexible element for situations with one fixed end and other subject to rotation. Here another joint, it's called here as you see, this is flooding modules. This is the flooding modules, and also it is part it's used also with the riser, as you see. Another thing, it's called intermediate. Here it's called intermediate flexible joint. The intermediate flexible joint is a double-ended version of the subsea flexible joint designed for installation below the telescopic joint. So this is below the telescopic joint, and it has the capacity to handle rotation angles up to 20 degree, axial tension up to 4,000 kilopound, and also pressure up to 3,000 psi. When necessary, it can also withstand extreme compression loading with limited rotation through metal-to-metal contact of the internal element. This is the intermediate flexible joint, as you see here. This is its shape, by the way, as I told you. And finally, the subsea flexible joint, which is in the lower part, of the riser. So the subsea flexible joint is used to couple the riser to the subsea stack. This is very important because this is directly above the VOP, so it can easily it's designed to operate in water depths up to 12,000 feet and is capable of angular deflection plus minus 10 degree and maximum axial tension up to 3,500 kilopounds. This flexible joint is also designed to withstand extreme internal pressures and tensions and rotations. Working pressure ranges from 600 to 6,000 psi. Okay. Finally, and this is the last thing in the it's about directly below the stack. This is part of the riser, but it's directly in from below. It's called the hydraulic wellhead connector. Hydraulic wellhead connector is directly connected to the BOP stack from below. So as you see, there is here for lock, for unlock, and for the released. Okay, and here as you see, this is used by using the hydraulic line. You can apply pressure, for example, from up. So once you apply pressure from up here on this area here, from here, so this cylinder comes down and it makes the locking segment to attach directly to this joint. So here you are locking. If you need to unlock, so you have to pump from here. So this area is less than this one, so it can open it and make this locking for it, or this locking or unlocking for it. Okay, so this is very important. This is very important, and this is a question in the IWCF. How you know? Because the area of locking is less than the area of unlocking, so this is very important question. By the way, here as you see, this is illustration for it. So this is primary lock position. You are applying pressure from here, so apply, this is the drilling fluid, this is the hydraulic fluid, it applies pressure from here, so this piston comes down. Once it comes down, this dogging element or locking segment is in the lock position. If you need to unlock, so you have to pump the fluid from this direction, okay, by the way, through this one, so it comes here. Once it comes here, you are making unlocking, so you have auxiliary also or secondary unlocking if you pump from down here, so it makes fully unlocking and it can be released. Okay, so this is very important. You have primary locking position and secondary unlocking position. This is very important. So as you see here, this is a latch segment lock, okay, and this is how directly this latch is retracted and unlatched automatically after you are applying the pressure. Okay, what about this pressure? A pressure can be up to 3000 psi, and this is also a question in the IWCF. Up to 3000 psi for wellhead connector, especially for Vitco H4. For Vitco H4, which is the most common, so this is the that's it, yeah. Okay, that's it today. Actually, it was very important lesson. Okay, let's see this video before we end this one. By the way, it's about the wellhead connector, as you see. This was our session today. I hope I could deliver it in easy way. Thank you very much, and see you later inshallah in the next session. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.